Hi, welcome back to 6.4 Arithmetic Sequences. In this example, we're going to determine a formula for the general term. Okay, so it says consider the sequence -13, -19, -25. Is this sequence arithmetic? Explain how you would know. Okay, so is this arithmetic? So does it look like it goes up by a common difference? So meaning is there some value of d that's being added each time to get the next term? So it looks to me like the first term is -13, and then it goes down by 6, and then it goes down by 6 again. So yeah, it does look like there's a common difference. So we can say by observing the sequence, we can see that the first term is -13, and each consecutive term decreases by 6. Okay? Therefore, it is arithmetic. Okay, part B, determine an explicit formula for the general term. So when they say the general term, they just mean like the nth term. Or even easier than that, you can think of it as just the explicit formula. So what would the equation look like? So what's our first term? And then, we're going to have a few numbers in here. So they want the explicit formula. So it's helpful to know what our first term is. That's -13. And we also know that because the sequence was decreasing by 6, we know the common difference is -6. So therefore, using our general equation, which is right here, we'll write it out. So the first term is -13. That's the a value. The common difference is -6. Okay, and all that I like to do here is just kind of clean it up from this point on. So um, we're going to write it as -13 minus 6n, because I got to distribute this -6 inside the bracket. -13 plus 6 is -7. So we would have -6n minus 7. That's my explicit formula. Okay, we'll do part C up here. Write the value of the 15th term. Well, now we want t of 15. Well, that's great. We can just use our explicit formula, plug in 15 for n. So -80 minus 7, we should get -87. Okay. Oh, actually, wait, that is 97. Okay, I was just kind of looking at that. -6 times 15 is 90. -90 and a minus 7, -97. Okay, so that's going to be our T15. Okay, and then last part, part D. So I'm going to try to give myself a little bit more space here. Part D wants the recursion formula. Okay, it says determine a recursion formula for the sequence. So remember, recursion formulas they have the form of that an nth term is equal to the previous term plus something or minus something. So because this is an arithmetic sequence, I know that my nth term is going to be the previous term plus the common difference, right? So it's going to have this form. Tn equals Tn minus 1 plus d, okay? So this is the previous term plus the common difference. And remember, that's kind of the instructions for an arithmetic sequence. We have a number, and then we add the common difference to get the next term. So what is the formula, the recursion formula for this sequence? So sometimes I find it helpful to write out each term. So the first term is negative 13. The second term is negative 13 minus 6. The third term is the second term, which is negative 19, then minus 6 again. So I also like to write it this way too as well. T1 equals negative 13, and then T2, I write it as T1 minus 6, and then T3 is equal to T2 minus 6. So it's really helpful to look at it this way because it shows you that each term is the previous term minus something. We can see that it's constant. So if I wanted to find the nth term, I would just take the previous term and then take away 6 from it. And that would be my recursion formula. So that's our answer for this one. Now, to do these questions, instead of writing this out here, I find it's helpful to just know this. And then whatever we calculate for D, which we already did a long time ago, we can just plug that in. And then you get your recursion formula. Okay, that's it for this example. I'll see you in the next video.